So when I simplify this, two negatives make a, so I got y plus 1 equals negative 1/2 times x minus 8. There's point slope form. Is that what the directions ask me to do? No, the directions ask me to write it in standard form. What is standard form?
ax plus by equals c.
ax plus by equals c. So that means get x and y on one side and numbers on the other. So I got a little work to do here. So what I'm going to do is I'm going to simplify a little bit. Bring the negative 1/2 through the parentheses. I got negative 1/2 x plus negative 1/2 of 8 is positive 4. Okay, that's good. I'm getting closer. I have to get x on one side and numbers on the other, right? So I'm going to add 1/2 x here. I'm going to x on the other side. I'm going to subtract 1 here. So I'm going to get 1/2 x plus y equals 3. Do I have x's and y's on one side? Do I have the numbers on the other? Am I in standard form?
Yeah. No, you have to.
Am I in standard form? Yesterday I mentioned in here, I said my rule of thumb is standard form does not have fractions. Do I have fractions in my problem?
Yeah.
I'm going to multiply everything by 2. I multiply by the common denominator. You know, as I'm getting the fractions the same, but I would look at it and say, what is my common denominator? There's only one denominator here, right? My denominator is 2. So I'm going to say, okay, I'm going to multiply everything, both sides, by 2. So if I multiply 2 times a half, what do I get? 1x plus 2 times 1y.
2y.
2y equals 3 times 2 is 6. Same equation, just a multiple of each other.
So to get to standard, you have to go through point slope.
Usually, yes. Now I want to just go off on a tangent for a second here. I want to talk about multiplying by 2 here. Let's say I have this equation. And I ask you, here, hang on, I'm going to change this number. That'll work. 4 instead. Okay, here's my equation. Put it in standard form. Is x and y on one side?
Yeah.
Yeah. Are fractions gone?
No.
No. So I have to get rid of fractions. What's my common denominator between 3 and 9? 9. Common is multiple. So I'm going to take everything, and when I say everything, I'm multiplying everything by 9. Okay? Now when I say multiply, I'm running it through the parentheses. I'm going to take this 9, bring it through. I'm going to take this one, bring it through. This one here, bring it through. Multiply everything by 9. What is a third of 9? 3. If I take 3, 1/3 times 9, I'm going to get 3. So I'm going to get 3. And then I still have the x there. Plus, what's 4/9 of 9? 4. If you don't know it, go like this. Go off the side. 4/9 times 9 over 1. That's what we're doing, right? 4 times 9 is 36, and 9 times 1 is? Which is 4, right? Like a 4y. Now on the other side, equals 4 times 9.
36.
Am I in standard form now?
Yeah.
Yeah, I'm in standard form. X and y on one side, numbers on the other, no fractions, right? Now, if you remember standard form from yesterday, standard form went like this. It went ax plus by equals c, right? Is that the form I gave you? A stands for the number in front of your x, B stands for the number in front of your y, and C is the number by itself, right? Here's a rule, not in your book. Okay, I want you to just write this down. Write me down what, on this equation, what is a negative A over B? Write that down. On this equation, what is a negative A over B? What is a negative A over B? And what is C over B? So if I was looking at this equation, what's my A? 3. What's my B? 4. So negative A over B is negative 3 over 4 here, right? What is C over B?
36 over 4.
36 over 4, which is? 9. Agree? A negative A over B, when my equation is in standard form, is my slope. Always. So this negative A over B, I don't have to get y by itself. I never have to get y by itself. My slope is always a negative A over B. If my equation is in standard form, I just say, okay, that's my slope. I don't have to do the work to get y by itself. That's more work. C over B, y-intercept. If I was graphing, I have my y-intercept, I have my slope. I just graph it out real quickly. So C over B is my y-intercept. Usually in my y-intercept, I will label my y-intercept 0, and that's kind of how I want you to do it. 0, 9. Y-intercept meaning x is 0, y is 9. I want you to label it as a point. Y-intercept is a point. It's not just a number, it's a point. So I want to write it as 0, 9. So we got these new equations here. We got this one. Slope is a negative A over B. Y-intercept is C over B. Helps you solve it down as you go through. But you only can use those equations when your equation is in standard form. Now, if it's in y equals form, let's use these equations. So only in standard form. Now, I could use these equations in standard form in fraction. I could. But my question to you is this. If I wanted to do a negative A over B here, which one's easier, negative 3 over 4 or a negative 1/3 over 4 ninths? Negative 3 over 4 is a lot easier, right? So if you got rid of fractions, this formula, these two formulas are going to be a lot easier to work with than doing the other way, right? And that's kind of why I say my rule says get rid of fractions, because it makes these two formulas easier. So, find the slope of a line. Let's just do it right now. Negative A over B and negative A over B and C over B. You have an equation of 4x plus 3y equals 7. Find me the slope. Find me the y-intercept. Write them down. Find me the slope and y-intercept. All those done? Can you get this one in? Fortunate. That's it. Find the slope and y-intercept. So my slope on here, if you remember, I do not have to get y by itself. I can just go like this. Negative slope is a negative A over B, which is going to be a negative 4 over 3. This was in standard form. That's all. I'm done. That's my slope. My y-intercept is C over B, which is 7 over 3. So my point would be 0 and 7/3, right as a point. Question on that? So now what I want you to do here is there's three types of equations actually. Now, what you want to do? We have point slope form. Y minus y1 equals m times x minus x1, right? We got standard form, ax plus by equals c. And we have slope intercept form, y equals mx plus b. So we got three different forms. And you have to know the difference between all three forms. Now, the last thing I want to talk about, I think it's the last thing we look here, yeah. Last thing is slope again. First thing is this, slope of a horizontal line. Slope of a horizontal line is parentheses. Okay, on a horizontal line, the slope is constant. Slope is 0. Slope is 0. And you just have to know that. Okay, there's no easy way to do that. The slope is 0 there. A vertical line. Vertical line is the slope is no slope.
I don't know if you want to start or you got something else to do, but the rest of the week sometime, go through the grades, the second quarter. You know what the grade percentage is, right? They're letter grade. Start putting them into the second quarter.
Okay, so this is all final, they're not gonna add any more?
If I have to, I'll change it myself, but just get them in there. Most of them are pretty much final. So if you want to start with the classes, you can.
Okay, you want me to start with first hour?
And I'll just show you on here. There, I don't know if I put first quarter in there. But if you go to home and under file preferences, you can change it to first quarter. And then just do the same thing under assignment scores and stuff. You'll see first quarter percentages and stuff. Grades.
Okay, you haven't done first quarter
I
yet?
don't know if I did or not. On mine here, I guess I did put letter grades there.
Okay, you want percentage or letter grade?
Just put letter grades for now. So you can just fold those over and put your second quarter in there.
Okay.
Okay?
Yeah.
Something done. Thank you.
Okay. Now the question is a vertical line. Why is my slope undefined?
Because on vertical, there's no slope, like it doesn't go over, it just goes straight up.
Okay. So I like to think of the name of it mathematically. You know, it doesn't go over anything; it just goes up, right? It's undefined. There's a reason it's undefined. And why is it undefined? What is slope again?
It's divides over 1, so it's 1 over 0, and you can't divide by 0.
Yeah. Yeah. On a vertical line, my x-coordinates are the same, aren't they? My x-coordinates are the same. If I take my x-coordinates that are the same and then 4 minus 4, I get 0 in my denominator, right? 0 in my denominator, in mathematical terms, for a better term, it blows up. Can't work. So therefore, it's undefined. I like to use the word undefined better than no slope. The slope is undefined because the denominator is 0. Sometimes some books use no slope. I don't like that definition as much. Now, those are two, vertical and horizontal. Okay. Perpendicular lines. Two lines that form a 90-degree angle. Okay? There's two ways to think about their slopes. First of all, their slopes could be, and I'll write this down, they use negative, so I always use, their slopes are opposite reciprocals of each other. Opposite reciprocals of each other. And that, what they mean by that is this. If one slope is positive, the other one's negative. One slope is 1/3, the other one's 3 over 1. Reciprocal means flip it. And opposite means opposite sign. To be perpendicular, they have to be opposite reciprocals of each other. So therefore, that's one definition. Another definition for perpendicular is the one right here, which says, if I take the slopes of two lines and multiply together, and it gives me a -1, they are perpendicular. If I give you two slopes and multiply them together, and they're -1, the lines are perpendicular. Whatever one works for you. I don't know what's easier. If I was telling if two lines are perpendicular, I'd probably use the bottom one. If I'm finding the perpendicular line, I'm probably going to use the top one. Opposite result.
Slope minus slope equals
Slope times slope.
-1. Slope times
Slope times slope is equal to a -1, then they are perpendicular. So. Okay, parallel lines. Definition always gets wrong. What are parallel lines?
Lines that never intersect. and
Lines
are
that
on the
never
same
intersect.
plane,
Was that?
And are on the same plane.
On the same plane, that's the key right there. On the same plane, they never intersect. Hopefully, in geometry, we talked about, there's two types of lines that never intersect. One was parallel lines, one was skew lines. You remember that back in geometry days? Skew lines are lines like, let's say that one going across the ceiling and the corner back there. Those are skew lines, but they're not parallel, right? Parallel lines would be like the two runners here off your ceiling tiles. Those are parallel, they're in the same plane. And they don't intersect. There is other ones that don't intersect. We get, and if you remember back to geometry, I taught geometry a few years ago. I don't know if Ms. Adler ever talked about this. When you do geometry, you'll notice that all the geometry techniques you talk about is called Euclidean geometry. Okay, I don't know if you ever mentioned that. Euclidean geometry is based on Euclid. He's the one that found most of the geometry. There is many forms of geometry. The one that most people teach is Euclidean. That's the one we teach most often. There is different forms. There's one called taxicab geometry. And I can't remember the other two I don't work with. There's different forms. In taxicab geometry, a circle would represent a straight line. Geometry based on, one of the geometries we deal with later on is geometry based on if there's no gravity. You know, a straight line, if you have a thing goes in a straight line, no gravity, that thing never really falls in a straight line. You know, so therefore, there's a different form of geometry there too. So there's when you learn the basics, it's kind of a weird thought, but the straightest distance between two lines, sometimes is a circle, meaning what you're working with. But in Euclidean geometry, you're dealing with skewed and parallel lines. Now, what are parallel lines? You said two lines that never intersect in the same plane, right? How can we tell about the slopes?
They have to be the same.
Slopes are the same, are they parallel?
Yeah.
Close.
They can't be the same line.
Can't be the same line. Slopes have to be the same, and the y-intercepts have to be different. That's to be parallel. So in other words, parallel lines, M1, let's go here, M1 and has to equal M2, let's say. Slopes have to be the same, but my y-intercepts have to be different. If the y-intercepts are the same, it's the same line, they're not parallel. The same line, because parallel lines don't intersect. If they're the same line, do they intersect?
Yeah.
All the time, right? So that's not parallel lines. So when we look at parallel lines, it has to have same slopes, different y-intercepts. Now this question down here, it says, write an equation of a line through each point. Let's go over here. It says, write an equation of a line through each point and perpendicular to this graph. And I guess I had more problems. I just did the one here. So my graph here is this: y equals 3/4 x plus 2. I want to go perpendicular. Perpendicular means form a 90-degree angle, okay? What's the slope of that line? 3/4. To be perpendicular, it would have to be -4/3. So the slope, just for symbol-wise, the slope I have to work with is perpendicular. Upside down T represents perpendicular. So that'd be perpendicular, right? And so therefore I got -4/3. If I was going to do this equation now, I'm going to use the point slope form. Y minus y1 is equal to m times x minus x1. Okay? So now if I went through here, I have my point. My point's right here, which is 0,4. And here's my slope I want to use that's perpendicular. So if I want to solve this in, I'm going to have y minus my y coordinate, which is 4, equals -4/3 x minus my x coordinate, which was 0. Plug it in. Now if I solve this, now I have y minus 4 equals, bringing the negative 4/3 through it, negative 4/3 x. Right? Is that, now, did I tell you what form to write it in? No. If I don't tell you a form, another thing I want you to understand, if I don't tell you a form, I want it in a standard form. Okay, unless stated, it should be a standard form. So like on this equation here, if I want to write this in standard form, I'm going to bring the 4/3 x over. I'm going to add 4 to both sides. So that's going to cancel, that's going to cancel. I get 4/3 x plus y equals 4. Now I'm going to multiply by the common denominator and get it in standard form, which would be 3. So I'm going to multiply by 3, and I'm going to get 4x plus 3y equals 12. Agree? Okay, that's standard form. Now if I look at these two equations, if I graph these on my calculator, what should happen? They better be perpendicular, right? But the thing I want to warn you, when you graph on a calculator, half the time it doesn't show up looking like perpendicular. Because the scales have to be exact to be right. If your scales are off by a little bit, it doesn't look right. For example, if I went in these two equations, I'm just going to do this one real quick. If I put this in point slope form, or slope intercept form, I'm going to have a negative 4/3 x plus 4. 3/4 x. What was the first one? 3/4 x plus 2, okay? First one I had 3/4 x. Now I hope most of you know that control divide gives me a fraction. And I have 3/4 x plus 2. There's my first equation. And my second equation was negative, and I think it was 4/3 x plus 4 is my second equation. Does it look like perpendicular?
Yeah.
That ain't too bad. This one's not too bad. But now, if your calculator was set up into scale format, I'm just going to throw this out here. And a lot of times people change these settings. I'm just going to throw out negative 6 to 6. Does that look perpendicular? Same equations, just different scale. So your scale, a picture doesn't prove anything. You know, like here I say, if I had this on a test, well, that's not perpendicular. But if I look at the equations are perpendicular. So you have to be careful with working with these scales on your calculator, because if your scales aren't exact, you have to make sure it's in the right form to see that perpendicular. Scales change a little bit. Questions? Kind of covers 2. I think I had questions on the homework yesterday. I think that covers some of the questions that people had from homework yesterday. Point slope, and perpendicular, parallel, and stuff like that. And you are working at the same page today, but 42 through 81. I can read. 42 through 81. Yep. Like 13 questions, I think. That's not too bad. So make sure you get that done. Are you gonna be around?